In this unit, we'll look at matrix algebra. So I've got a new note file here, and we'll start with what we call the transpose operator, which you may have seen before. This is how you take a row vector and turn it into a column vector, or vice versa. So if I have a simple row vector 1, 2, 3, and I want to transpose it into a column vector, now it's a column vector. Another operator is the dot product. So if you've taken a vector calculus course, you may have seen this, or some physics classes. What the dot product is, it's defined between two one-dimensional arrays, A and B, let's call it. By definition, A dot B, I'll use a period here, A dot B is the magnitude of A times the magnitude of B times the cosine of the angle between them. So I'll just call that theta. There's also an algebraic version, and this is the one you use when you're calculating if you have component form of your vectors. So it's the sum of the products of each array, element by element. And MATLAB is really good at helping us out with that. So let's take a look. Let's make A equal 1 to 4 and B equal, let's pick some even numbers, 2, 4, 6, 8. So I have the same number of elements in each one. And now I'm going to define C as, let's just start with A times B. So this is the dot multiplication we've done before, where each element of A is multiplied by each element of B. So we get 1 times 2, 2 times 4, 3 times 6 is 18, and 4 times 8 is 32. That's one way of multiplying two vectors together, element by element. But so this is the old school style, element multiplication. What we're going to do differently now is take each element of A, multiply it by the element of B, and add them all together. So we're going to get the same thing as sum C. I'll go ahead and just run this real quick so we can see what the answer is supposed to be. 60. Now there's a shortcut way to do this though, that we don't have to multiply and use the sum. We just use the word dot. So let's call it D. D equals dot of A and B. So dot of A and B together needs two inputs and they have to match in size. Run section. Let's close that out and see if we get indeed a 60. And we do. So D equals 60. That's the dot product. Notice that the dot product of two vectors is a scalar. That should sound familiar. Let's try something different. If I do dot of B and A, do I get the same thing? Yes, because both multiplication and addition are commutative. So no matter which order we do the multiplying in, no matter which way we add, we're going to get the same sum. So dot product is commutative. But both arrays must have same number of elements. Notice both must be either row vectors or column vectors. You can't mix. So that's the dot product. Let's do a quick example using the dot product. I'm going to paste this in actually. So let's say I'm selling 3 different products with 3 different prices. So $5, $7, $50, and $100. Those are my 3 different prices. I sell 12 of the first, 9 of the second, and 4 of the third. So we can find the total revenue pretty easily by multiplying. Let's make this one the costs. I'll call it costs. Costs are 5, 750, and 100. And then the number of products sold, so I'll call that quantity, for Q for quantity, or that's how many I sold. I was 12 of the first, 9 of the second, and 4 of the last. Oops, forgot a bracket. Now, Excel has a function to do this, by the way, also. If you're in Excel, it's called sum product. But in MATLAB, it's a little easier. We just say revenue equals dot of costs with quantity. And then let's print that out in a nice sentence, actually. Let's format bank and say, let's make a string real quick. the total revenue is $, and then I'll use num2 string, that's the revenue, and then add, I forgot a comma, and then add a period. And do I need to see that? Let's do this, display X. Let's try it. So I'm suppressing all the input up until I get to this last sentence where I'm displaying the string I called X. Run section, total revenue is $527. This seems like a lot until you remember that one of the products cost $100 and we sold 4 of them. So that seems like a reasonable amount. All right, in our next video we'll look at some other matrix operators.